by Melvin Berger. Electricity. Light our lamps, warms our heaters, spins our fans, moves our trains, carries our voices over telephone wires, brings us sound and pictures on TV, runs our computers. But what is electricity? We can't see it, we can't hear it, we can't smell it. Electricity is a form of energy. Energy is the ability to do work. The energy in our muscles let us walk, talk, eat, and play. The energy of jet engines speeds airplanes through the air. The energy of wind turns windmills and pushes sailboats. The energy of wind-up toys makes them move. Electric energy comes from electric generators. Generators are machines that produce electricity. You can make your own electric generator. It's easy. Do it yourself. Make an electric generator. Collect a piece of electric wire about 2 yards long, a bar magnet, a compass. Ask an adult to peel 1 inch of covering off both ends of wire. Wrap one end of the wire around your hand about 10 times to form a coil. Slide the wire off your hand. Wrap the other end of the wire around the compass about 5 times. Leave the wire there, twist the 2 middle ends of the wire together. Now slide the magnet quickly back and forth inside the coil. This makes electricity flow in the wire. You have made an electric generator. Look at the compass. Is the needle moving? The moving needle tells you that electricity is flowing through the wire. This is how it works. The wire is made up of billions and billions of tiny bits. These bits are called atoms. Atoms are much too small to be seen, but inside each atom are even smaller bits. They are called electrons. The electrons spin around the atom center. Sometimes the electrons move from one atom to another atom. Moving electrons produce a current of electricity. When electrons move through the wire, electricity flows through that wire. Moving a magnet near wire sends the electrons from atom to atom. That's why electricity flowed from your tiny generator. But only a little electricity came from your generator. A powerful flow of electricity comes from the giant generators of electric companies. Giant generators have huge coils and magnets. In most generators, the magnet spins inside the coils. In some generators, coils spin inside a magnet. The power of your tiny generator came from your muscles in your arm. The power for most giant generators comes from burning fuel. The burning fuel heats water. The water changes into steam. The steam pressure spins the magnet in the generator. This is a big generator. The electricity from the giant generators goes into big wires. These wires run along the tops of all tall poles. In some cities, the wires are under the ground. The electricity travels through these wires for many miles. The long wires have short branches. They bring electricity to homes, schools, stores, and other places. One of these wires goes to your home. Inside your house are electric wires. The wires bring electricity to everything that needs it. Lights on the ceiling and walls use electricity. These lights are called fixtures. Appliances in the home use electricity too. Appliances have wires with plugs. The plugs fit into outlets in the wall. Some common home appliances are refrigerator, microwave, and dishwasher, radio, TV, and computer, lamps, fans, and heaters, toaster, blender, and coffee pot, clock, iron, and air conditioner. The electricity that comes into your house is very powerful. It is also dangerous. It could give you a severe shock. So be careful around electric fixtures and appliances. You can check your home for electrical safety. Do it yourself. Be an electric detective. Take a walk around your house, look for signs of danger. Look, but don't touch. 1, fixtures that don't work. 2, broken appliances. 3, torn or frayed electric wires. 4, 3 or more appliances plugged into one outlet. 5, outlets without safety covers. 6, people unplugging appliances by pulling the wire, not the plug. 7, people leaving lights or TV on when not in the room. And here are some examples of what you can check for. We plug appliances into electrical outlets, but what if we want to carry a flashlight outdoors? Then we use a battery to give us the electricity we need. Would you like to make a battery? Do it yourself. Make a battery. Collect a soup bowl half filled with water, about 4 tablespoons of table salt, a paper supermarket bag, a can of scouring powder, 5 shiny pennies, 5 shiny nickels. Pour the soap into the water and stir. Cut out 9 1-inch squares of the paper bag. Cut the soak Soak the squares in the salt water. Hold the pennies and nickels under warm tap water. Scrub both sides of each coin with scouring powder. Rinse the coins in tap water. All right. And here's some steps to do that process. It's pretty cool. Make a battery. Need a spare. Make a stack of coins in paper. Nickel, wet paper, penny, wet paper, nickel, wet paper, and so on. The coins in wet paper work like a battery. They produce a small flow of electricity. Dip your fingers in the salt water. Hold the stack with your thumb at the bottom and pointer finger at the top. Do you feel it tingling? That's a very mild electric shock. The mild electric shock comes from the battery. It makes electricity just like the generator. The electron speed from atom to atom, this form of electricity is called current electricity. Now you have yourself a spare battery. There is another kind of electricity. It's called static electricity. In static electricity, the electrons don't flow from atom to atom. They just get knocked off some atoms. Do it yourself. Shock your friends. Slide your feet on a rug or carpet. This works best if it's a cold, dry day. Now touch a friend's hand. You'll both feel a mild electric shock. Sliding on the rug knocks electrons off some atoms in your body. It gives your body a charge of static electricity. Touching your friend lets the electricity jump from you to your friend. You can do some fun tricks with static electricity. Do it yourself. Electrical balloons. Blow up a balloon, rub it quickly and lightly against something made of wool. A woolen sweater, skirt or trousers, woolen gloves, scarf or socks. The rubbing gives the balloon a charge of static electricity. Now hold the balloon against a wall. The balloon sticks there. It's static electricity at work. Again, rub the balloon against wool to give it an electrical charge. Hold the balloon over someone's head. Does the person's hair stand up? It's static electricity at work again. Next, blow up 2 balloons, tie a string to each one, rub the balloons with wool. Now they both have a charge. Hold the end of each string. Try to bring the 2 balloons together. Can you do it? No. The static electricity pushes them away from each other. Like polar ends of a magnet. You can do other static electricity tricks with a comb. Try these. Do it yourself. An electric comb. All you'll need are a tissue torn into very tiny bits, a handful of dry puff cereal, a clean pocket comb. Hold the comb with your fingertips. Rub it on something made of wool or run it through your hair a few times. Quickly pass the comb over the torn up tissue. What happens? The paper bits jump up and stick to the comb. It's static electricity at work. Wait a few seconds. The electrical charge starts to grow weak. The bits of tissue fall off. Try this experiment again with dry puff cereal instead of tissue. You made static electricity by rubbing with wool. The static electricity pulled things together and it pushed them apart. You can use static electricity to make a tiny spark of electricity. The spark is very weak. It can't hurt you, but the spark is like a tiny, tiny bolt of lightning. Do it yourself. Make lightning. This activity will only work on a cold, dry day. In a dark room, rub a comb with a piece of wool. Quickly hold the end of the comb to a metal doorknob. What do you see? A small spark jumps between the comb and the doorknob. This is something like lightning. What do you hear? A crackling sound. This is something like thunder. You can almost storm in a house. Real lightning is a giant spark. No one is sure what causes the spark of lightning. They know it mostly comes on hot, humid days. On some days, a big, dark thundercloud forms in the sky. Drops of water and bits of ice are in the cloud. Winds in the cloud blow the water and ice up and down. They rub against each other. It is like you rubbing a comb with wool. The electrons are knocked out of the atoms. The charge of static electricity grows bigger and bigger. Then suddenly, a giant spark flashes across the sky. That's the bolt of lightning. Lightning can jump between a cloud and the earth, or it can jump between two clouds. After you see the lightning, you hear the thunder. The lightning makes the thunder. A lightning bolt is very, very hot. It quickly heats the air it passes through. The heated air explodes in all directions. Thunder is the sound of the exploding air. The static electricity you make at home is safe, but lightning is very dangerous. If you are outdoors when lightning flashes, go into a house or automobile, don't stand near a tall tree or pole, crouch down in an open field, don't go near water, don't touch anything made of metal. If you are indoors, stay away from doors and windows, stay away from sinks and tubs, don't use electrical appliances, only use the phone in an emergency. Current electricity is also dangerous, but you'll be safe if you are careful, and you'll enjoy all the wonders of electricity. The end. All about electricity.